Hey everybody, welcome back to another edition in geometry. It's Mr. A here. Welcome back. We're in section 7.5 today. We're going to talk about the parts, some different parts of similar triangles. We've been talking about similar triangles, so we're going to look at different parts. So first of all, our objectives. Number one, recognize and use proportional relationships of corresponding angle bisectors, altitudes and medians of similar triangles. You remember we talked about bisectors, altitudes, and medians earlier this year, and so we're gonna talk about that within similar triangles, and then we'll use the Triangle Bisector Theorem. All right, first of all, this is dealing with the altitudes. Okay, so we're talking about altitudes here, and remember what we know about similar triangles. So this tells us here ABC is similar to FGH. So we know, remember, that all those angles, angle C, the whole entire angle A, the angle B, all match up with H, F, and G. And then we know that in similar triangles, the sides are, the ratios are proportional. So the AC over FH is the same as AB over FG, which is the same as CB over HG. We know all of that. Well, what we're saying here is, in addition to that, you also know that the altitudes are in that same exact ratio, okay? So, for example, and here's kind of why, just a quick little thing on why. We know all the different sides are in the same proportion, but if you look at it, since you know then these two triangles are similar, we know that C and H have to be the same. If you just look at the triangle, say over here, that's made by the 90-degree angle, what do we know? We know that the two 90-degree angles are the same. The one mark on C and H, that those tells us those are the same. So that means this CAD has to be congruent to HFJ. So therefore, these two triangles to the side here are also congruent. And so guess what? All their sides are in the same ratio as the sides of the big triangle. So that means that AD, and this is what they say here, AD over FJ, here's the AD over FJ. I'm going to write it out again just to emphasize it here. So AD over FJ, that has to equal the ratio of every other side. So they said AB over FG, which is good, AB over FG, but it's also proportional to BC over GH, and that's also proportional to AC over FH. So we already know all this stuff. We know these three here because they're similar. This was the new part that we didn't know, but now we do. We know that the ratio of their altitudes is the same as well, okay? What about angle bisectors? Well, guess what? No surprise. It works the same way. And so that in this case, remember, the angle bisector is the line that takes one of these, that splits the angle into two exact same things. So here, angle KLP is equal to PLM, and QRT is equal to TRS. So in an angle bisector, the same thing happens. So again, if you look at the two lines here, LP, I'm going to rewrite this so we know that LP is an angle bisector. Well, if you put that over RT, that will equal all of the other sides as well. So the one that they started out with here was LM. So they said LM over RS, which is good. But also SQ over MK would also work. And it would also equal QR. Wait a minute. Did I really do that? Can you believe that, guys? What did I do wrong? I did LP, LM, and then why did I start with SQ on this one? I don't know. But it should be the other way around. So MK over SQ. Because that's also important here too, that since I'm putting LP, LM, I'm putting all the letters from that triangle on the top, I have to continue doing that. So then the final step is I did MK over SQ, so I have to do KL over RQ or QR. Okay, so there you go. All right, but the point there is all the sides are proportional, they have the same ratio, so if it's a angle bisector, they're also in the same exact ratio. And here are medians, and guess what? It's the same thing. So again, you notice now a median, remember, goes from the point here, the vertex of the triangle, and it splits the opposite side into two equal parts. And so that's our median, and so we would say again, well, that's CD. So CD over YZ, that's the ratio of the medians. Well, that's going to equal all the other ones too. So they started out by saying AB over WX. But not only AB over WX, it's also BC over XY. And that's also then CA over YW. So again, we know this third part. We know all those sides are proportional, and now we also know that medians are in that same proportion. So when you go to solve problems with any of these, you don't have to know all of them. All you have to do is know one part. So like if you know one of the medians and you're trying to find the other median, all you need to know are two other sides in this triangle. You don't have to know all of these. All you have to do is just pick one of these to work. Okay, so let's look at a few examples here. All right, this is altitude. Okay, so remember again, you know, the altitude goes from the vertex straight down, makes a 90-degree angle. And so what I start with usually is, now this one's kind of easy because it's all set up in the same way, but I usually like to start with the special segment itself. So in this case, the altitude. So it's a 6 and a 9. So again, whatever way you set that up, you have to keep it the same the whole way through. So if we start out with, say, 9 over 6, and if you wanted to, you could reduce that fraction as well. That would be totally fine. But if I do 9 over 6, well then what's the sides that match up? Well, you notice it's AB matches up with FG, so it'd be 21 over X. Once we have a proportion set up, what do? Cross multiply. Okay, we've been doing that for quite a while now. So this would just be 9x equals 6 times 21. And 6 times 21 would be 126. So 9x equals 126, and divide by 9. And it looks like x is 14. Okay? Make sense? All right, so we're doing, you know, just like we would any other side, we also can do that with altitudes. Here's one with angle bisectors. Now this is a little bit trickier because now the figures are spun around a little bit. You notice the angle bisector here starts up in this corner and goes down, and here it starts here and goes over. So in this sense, and now it's not super hard because there's only a couple numbers, so we're good there. But if there are other numbers, you know, set in here, you have to make sure you match up the right ones. And so again, what I like to do is I like to start with the special segment itself. So in this case, the bisector, because that's easy to pick out. I can see this one's X. So I saw, well, this is X, and the other one is 8. So I usually start with those because that's easy to see. Now, in this case, there's only two other numbers, so we know it's got to be the 15 and the 12. But let's see, well, why does that work? Well, remember, since this was like the two angles that were split off here by the angle bisector, well, that matches up with this. And if you notice, if you this would kind of flip up and around. And so, well, here's the other thing. Actually, let me say it this way. This might be easier. Just look at this. Look at the similarity statement. So we know that if A and F match up, which that's the angle that got split, what else matches up? B and D. So when I do this side that goes from A to B, that's going to match up with the side that goes from F to D. So that's the easiest thing, is just look at the similarity statement. So we can see that the 15 and the 12 are the ones that match up there. All right, so if I did X on top, that means I need to do 15 on top on this one. So 15 over 12. We've got our proportion, and so what do? Cross multiply. And so that means we're going to get 12 times x, and that will equal 8 times 15. And 8 times 15 is 120. That's an equal sign. And then divide by 12. And so x equals 10. Okay, and again, if you want to double check yourself, you're like, oh, I'm not sure if I got that right, just plug x back in and see if these two sides equal each other. If you do 10 divided by 8, see if you get the same thing as 15 divided by 12. You should get the same number. That's how you can check yourself. All right, what about, here's an example with medians. Now this one's a little bit tricky for another reason here, but let's see what we can do here. So we got a median. It splits, again, remember the median goes from the vertex. It splits the opposite side into two equal parts. So we say, all right, well, let's start with setting up the ratio of the median. You got, what, 8 and 12 here, right? So I'm going to do 8 over 12. And now, whoa, well, this looks a little different because we don't have one whole side that we can set up. We've got, on this one, between S and T, it's 5. And on this one, between J and M, it's X. Well, before we talked about the whole side and the whole side, and we don't have the whole side. You could approach this two different ways. Here's the thing is, since it's a median, remember it splits these into two equal parts. So if that side's X, this side is also X. And here, if that's 5, this side is also 5. So if you want to, now knowing that, you could just go, oh, well, this whole side is 2x, and that would be proportional to 10, 5 and 5. And I'm going to simplify it here, but you could say, oh, that would be like 2x. Again, got to make sure I did 8 on top, so I got to do 10 over 2x. I'd have to do it that way since I started with 8 over here. If I do that, though, what's 10 divided by 2? It's just 5, right? So this would just be 5 over x. Could I not just set that up and use that right from the start, 5 over x? So if you notice here, once you figure out that these two are the same, this part, the half of this side, is also proportional to the half of this side. And same thing on this other side here too. So if you see that with a median, you don't have to do the 2x and the 10. You can just do the x and the 5, and that would be fine. It'd be a little simpler. And as always, you could have simplified this fraction, this 8 over 12 here. You could have also simplified that to make it easier. So this is 8x equals 5 times 12. And 5 times 12 there would be, what, 60? And divide by 8. And 60 divided by 8 looks like it's 7.5. Now in this case you might say, oh, 7.5, is that really correct? You could just plug this 7.5 in here, divide this out, see if it's the same thing as 8 divided by 12. If it is, you got the right answer. So again, that's how you can check yourself. All right, the last thing that we need to talk about here is the Triangle Angle Bisector Theorem. This is different. It's, again, dealing with an angle bisector, but it's different in the sense that we're only going to have one triangle, not two similar triangles. And if you notice here how this is marked out, you notice from J to K and K to M, they've marked that as red, and M to L and L to J is blue. Here's the situation they've given you. There's another way too, which actually I tend to like a little bit better. For some reason, it's just easier to remember. But let me explain this. It says Km over Lm. So if you took this side here, this one red side, the Km, and you put it over, or vice versa, ML, like you made a ratio out of Km and ML, that would equal the ratio here of the other sides, the full sides. So these are the sides that got kind of split up, that ratio is the same as these two sides, so JK or KJ over JL or LJ. The other way that you could set this up, which will work, and I don't know, I always seem to remember this one a little bit better, is you can just take the KM here and put it over JK. So put the red part, the red side here over that red side. So KM over JK. And that would equal ML, ML over JL. So you do like this part over that whole side and then this part over that whole side. For some reason, I tend to remember that better. But either way will work. And if you notice, here's why it works. Look, when you cross multiply, you get Km and Lj. And when you cross multiply here, Km and Lj or JL. And then the other way, you get Jk and Lm. And here you got Jk and Ml or Lm. So you end up cross multiplying with the same things. And so either way you set that up, it'll work. So let's take a look at something with that. So here we have one triangle. It's an angle bisector because you notice the two marks here. And so again, the way that I tend to think of it first, to me that's just easier. I like to think of 6 over 9 would equal x over 15. You know, the other way that you could do it, again, you could have done 6 over x or x over 6, either way. Again, whatever way you do it, keep it in that same order. So if I did 6 over x, on this one I would want to do 9 over 15. Okay, so I could do it either way. And if you notice, it's going to be the same thing both ways, that if you cross multiply, you're going to do the 9 times the x. Here again, the 9 times the x. And then when you cross multiply the other one, 6 times 15. And of course, this way also, 6 times 15. So you're going to get the same answer there. So 6 times 15 is 90. Okay, I didn't do that on purpose. And then divide by 9. I really don't know how I end up making these marks. I'm not even like touching the pad when that happens. It just goes. So x equals 10. Okay? All right, I think this is the last one here. Ooh, a little tricky one to end with here. Oh, what can I do? Well, number one, okay, first of all, it's one triangle. It's an angle bisector, so this is going to work. But here's a weird thing, though. We've got, the way it's marked out here, we got our x, our 14, our 11. But before, remember, we had a number here. Now they told us not what this number is, but the whole length is 20. Ooh, what can I do there? Okay, first thing you want to do is, let's figure out what could we call this short length over here on this side, opposite of x. Well, if you know the whole thing is 20, and you know this part is x, what's left over? Well, you take 20 and you subtract x, right? So we're going to call this short part here 20 minus x. Okay, does that make sense? So what you have to do in order to set this up, we have to determine what we're going to call this, and we're just going to call it 20 minus x. That's what's left over after we take away x. So now let's set up our proportion here. So I'm going to do x over 14. So that's this over that. And then over here I would do 20 minus x on top over 11. And then we're just going to cross multiply. So 11x would equal, now remember too, when you cross multiply, now that we have a binomial here, think of those as being in parentheses. So this is going to be 14 times parentheses 20 minus x. We're going to distribute that 14. So 14 times 20 is 280 minus 14x. And this will still be 11x. So I'm going to do plus 14x. So this is going to be 25x equals 280, and then divide by 25. And so 280 divided by 25 gives me 11.2. So x would be 11.2. And if you wanted, you know, we were just trying to find x, but then if you wanted to find out what the other part was, you just do 20 minus 11.2, you get the other part. And if you do that, you could double check and do those ratios and make sure they divide out to be the same numbers. All right, so that's it. Hopefully, oh, look, there it happened again. I didn't even touch it. But speaking of which, hopefully you liked my purple ink today. I thought I'd do something different. But anyway, that's it for today. Appreciate you being with me. That's all we got for section 7.5. This is Mr. Anderson saying so long. See you next time. Bye.